All right, so I'm going to walk us through, and I apologize if you're still working here, the solutions to these. So the very first one is the INT function. So g of x equals the greatest integer of negative x. What does the negative x in there do? How does it transform it? You make the x negative. Josh? Yeah, so this is going to be a y-axis reflection indicated by the negative x. Sorry, overshot it a little bit. There we go. So we're going to do a y-axis reflection of our INT function. So it's going to take all these little steps and rotate them the reverse way. So the bubbles are on the opposite sides. Okay, so that is INT negative x, because we flip the entire function over the y-axis. Then we have a bunch of transformations of b. So if we're looking at b, I'm just going to scooch it up a little bit. Guess I'm not. So what does the negative x do? Yeah, so that's a, thank you, y-axis reflection. And again, to figure out what you do in which order, you go from the inside out. So you start with the x is negative. So that's a y-axis reflection. Now, what does the 2 do? So far, we're just like right here, okay? I've just taken it and flipped it over the y-axis. So if you can picture what it looks like, Josh, what does the 2 do? It moves it to, now I want you to picture, if this was plus 2, right? If this is plus 2, so square root of x plus 2, it moves it 2 to the left, right? And this is adding 2. But I have taken my function that normally goes like this, and I have flipped it over. Now, notice here, my right point, my left points this way, my right points that way. But do you see how when I flip over, my right and my left are switched? So if you flip the function over, the right and the left are switched. So adding 2 is really going 2 to the right, because you have flipped that puppy over. Your right becomes left, your left becomes right. And the way you check your reasoning, if I move that 2 to the right, 1, 2 to the right, what's my x-intercept, you guys, now? 2. Now, if I plug in 2 for x, is y 0? Yes, it is. So you check to make sure your intercept lines up with your function, okay? Your x-intercept, I said to move it to right. I moved it to right. My x-intercept is now 2, 0. If I plug in 2, I get 0. All right, now we have to deal with it being a 4. So that 4 on the outside is a vertical, because it's on the outside, stretch. So it is a vertical stretch. In other words, all the y values are multiplied by 4. So picture this. If I am at this point right here, which is where it hits the x-axis, does my y value change at this point 2, 0? Would my y value change there? No. Now moving 1 over. This y value, 1 over, is actually supposed to be 1, because the square root of 1 is 1. So instead of this here, right here, being at 1,
where should it be at? 4. So I'm going to take that and move it up 4. 1, 2, 3, 4, right there. So instead of it being at 1, this is supposed to be at 1, it's at 4. So everything in terms of y value is multiplied by 4, and that's how we accomplish this vertical stretch. It's very stretched out. I could also do the point, like when you're looking at the square root function, the square root function, typically, if we do x and square root of x, it's x is 1, y is 1, x is 2, then it's ugly. So if I go x is 4, y is 2. So when I'm graphing the square root function, I look at 0, 0, because the square root of 0, 0, 1 is 1, 4 is 2. But then if you're looking at x and 4 times the square root of x, it's 1 and 4, 4 and 8. Okay? So it's going to be, instead of from here, you have 0, 0, and then we have our version of 1, 1. And then we could go to 4, 2, but now it's 4, 8. So all the y values are multiplied by 4 if I'm just considering the stretch. So it's like, all right? But 0 stays 0. That's why it's still glued to that x-axis, because if y is 0, it doesn't matter if I multiply by 4. Questions on that? All right, let's go over to this slide where I think I'm going to actually blow this up, since now we don't need to look at the first slide. Okay. So take a look at my function. This is h of x. You can see it's definitely going to be a piecewise function pieced together between two linear functions. It's constant, and then we have a slope of 1/2. What happens if I take h of x plus 3? What is done during that transformation? Come on. No. Josh? Up 3. Yeah, because it's on the same, it's h of x plus 3, so that's just an up 3. Yep. Yes. That is exactly correct. Yeah. So we're going up 3, so we're going to take that entire function and move it up 3. 1, 2, 3, and then we'll draw it up 3. How about h? Ava?
I'm confused about that. Didn't you say if there was y plus something, it'd be down, and y minus something?
I think what Tara said is going to help us. This is y equals h of x plus 3. So y minus 3 equals h of x. So therefore, it is up 3.
Oh.
Again, a little bit regretting how I presented it to you guys yesterday, because this is, I was really sold on it, but now I'm not at all. So I apologize. But plus 3 on the outside. And again, if we oriented it how we oriented yesterday, it does look the same. So it's the same math. It's just a different way of looking at it. So how about h of x minus 2? What is that going to be? Claire? Nope. It's done to the x.
Oh.
Andrew?
Oh, I would say equal
Right 2. So that one is right 2, because it's done to the x. So if it's done to the x, it's going to be left or right. Subtracting is right. So I'm going to take this whole thing, move it right 2. Let me actually move this. So right 2, I moved the starting point right 2, and then I'm going to just continue sound about right too. So it ended at 6, now I want it to end at 8 for right. Questions on that? Okay, now let's look at negative h of x. What does negative h of x do?
It's no longer x-axis.
Yep, it's an x-axis reflection. So x-axis reflection. Because it's being done to the y. It's being done to the h of x, which is the y. So you're going to flip it over the x-axis. So I'm just going to move it up a little bit. And I'm going to flip it over the x. Something like that. So this started at 2. This is going to start at negative 2. Be flat for a while, for those 2 units, and then go down to negative 6. That's our x-axis reflection. And how about D? Andrew?
It would be a y-axis reflection, so we'll just go with a y.
Yep. So a y-axis reflection, right there. So if we're taking this graph, flipping it over the y, actually I have to give myself some room. It's going to be flat, and then there I have flipped it over the y. So axis negative is the y-axis reflection. F of x is negative, it's an x-axis reflection. So x is negative, y-axis reflection. Y, or h of x, is negative, x-axis reflection. And if you are adding to x, it moves it right or left. Adding to the outside of the function or adding to the y, it moves it up or down. Okay? Are there questions? Okay. So right now, what we are going to do